Hi everyone, and welcome back to week 2, where we're going to talk about R and RStudio. Now, I realize for your assignment 1, you guys got a brief introduction to using R and RStudio. You learned how to set it up, read a data set in, but I wanted to take the time to explain to you both some basics of how to use R as a programming language, but also to help understand the motivation for learning R in the first place, because there are a lot of different statistical programs, and R can be especially finicky. And I know when I first learned R, it wasn't well explained to me why it was useful to learn R versus something like SPSS or doing things in Excel. So I'm hoping I can help you better understand why we're going to the trouble of using what is sometimes a finicky language, as well as give you some tips and tricks to help you better use the R language itself. So the main reason to use R is because it is infinitely easier to do statistics with a computer by hand. Arguably, you can't even do most modern statistics by hand. It would just straight up take too long. That said, that doesn't explain why we would use R specifically versus something else like Stata, SPSS, Microsoft Excel. The main reason to use R is because it's straight up more powerful than any of those other programs. It gives you, by actually writing the code, it gives you a lot of control over what it is you're doing and how you're implementing your particular analyses. And it particularly gives you more control than something like a spreadsheet, like Microsoft Excel. You can basically do anything you want in R. I mean, people make art in R. Like you can do anything. It's incredibly powerful. Another big selling point is that the software, so both R and RStudio, is free. So that means right now you as students don't have to pay for something. You're also not dependent on a company paying for some software for you. Whereas if I were to teach you in SPSS, maybe the university would help provide that software for you so you wouldn't have to pay for it now. But if you were to ever try to use these skills in like a corporate or business setting, you may or may not have access to SPSS. They may only provide for you Excel or something like that. Whereas R and RStudio are always free. It doesn't matter where you are, you can use these programs. And finally, I like teaching students R because it is, in fact, a real programming language. I often refer to it as a statistical programming language because it specifically does stats, so it's not going to like do a lot of other coding type things that other coding languages can do. But it will teach you the foundational principles of coding. It will get you comfortable with variables and assignment operators and different types of variables, whether they're string variables, characters, numbers, doubles, all of those kinds of things. And so even if you're not using R in the future, it does make learning other similar languages easier, such as JavaScript and Python. So for instance, I taught myself JavaScript at one point after learning R, and I found the process very easy because even though some of the details of how, for instance, you indicate what thing is a variable or how you execute a command is a bit different between the two languages, the underlying principles were the same. So that made it really easy to go from learning one to learning the other. Now, on the face of it, learning to code might not seem like a very good motivation for you. I realize a lot of people that take this online master's course are working professionals, and you might think, oh, I have no interest in learning to code. I have no professional ambitions for coding. But it's still useful to learn to code because it is a type of job security and mobility. So R is growing in popularity. More and more people are using it, but there's still a really high demand for people who know R, and there's more demand than there is a supply of people. And so even if you don't think you're going to want to use R, it may actually help you get a job in the future if you can be the kind of person that says, oh yeah, I'm familiar with that. I can, at minimum, work with other people that use R, even if you're not running the analyses yourself. And even if you don't use R, you may want to learn a different programming language to get a better job or raise or promotion. Again, this is a really common way for people to increase their salaries, is to have some passing coding familiarity. And so even if you're not using R, because it will help you learn a different language, you're still being set up pretty well to, again, have this job security, even if you don't think you need it right now. It's also becoming the new standard for scientific research. So in 10 years' time, it might be really common and you might be regularly interacting with people that use R. And if you're fluent in at least talking about R, that's going to give you a leg up over potential competition. Now, if you're taking this master's course because you're thinking about being a PhD student, learning to code in R helps you even more, partially because there's an increasing expectation of coding familiarity, so more and more programs expect their students to know how to use R. Also, many graduate courses like this one rely on R or Python, and a lot of them are not going to be as gentle in introducing to you how to use R or Python. Like they'll just kind of throw you into it. And finally, it will help you stand out to potential supervisors because, again, there's an increasing demand for using R. A lot of supervisors know that they should be using R, but they don't want to take the time to learn. And so if you're a potential grad student who says, oh, I know how to do this, they're going to want you because you can help them learn R. That's what I did with my advisor. I know lots of people where that's happened. And so it gives you a leg up on the competition as well if you're trying to get into a graduate program. So I just want to clarify what I mean by R and RStudio. So R is a programming language for statistical computing and graphics. That's its like official definition. So it's a programming language just like JavaScript, Python, C++, insert coding language here. RStudio is what's called an integrated development environment or an IDE. Uh, Basically, it makes using the R programming language visually nice. You can actually use R without RStudio, but then you're relegated exclusively to like command line interfaces, and it's just not as nice to use. RStudio also provides other useful tools, so you have like multiple windows, there's keyboard shortcuts, there's various ways to render and depict output. It also integrates with other things like Git and GitHub, and you can see your environment, like what variables have you created. It's just generally a nicer experience. It also now has like a what you see is what you get kind of writing editor. So if you want to write papers in RStudio, it's a lot nicer to do that. You can't do that in R. And so pretty much anyone ever who uses R runs it in RStudio. So anytime I'm talking about R, assume that we're talking about using R in RStudio. We're never going to run R by itself. So I'll use the two terms interchangeably and just think about them as the same thing. Because I suspect many of you may not come into this with any coding background whatsoever, I want to tell you some features of the R language, basically setting down some terms so that when we're talking about certain things in the future, you know what we're talking about. So a key feature of R as a programming language is that it has these things called objects and assignment operators. Objects are some string of letters. So in this case, you can see like myVar is a string of letters that can hold values. Values can be almost anything. It can be numbers, data sets, vectors, etc. An assignment operator is the thing that points to the object you want to store something in. So you can see in this picture, we have various things that are being saved to something called myVar, myVar2, myVar3. So for the top one, I'm saving the number 2 into basically a little placeholder called myVar. And the reason I want to do that is because I might not want to type 2 over and over again. Or if you look at the bottom for myVar3, I've created a vector there, which is like an object with 3 numbers in it. I might not want to type those 3 numbers over and over and over again because maybe I need to use them in a bunch of places in my code. And so it's a lot easier if I can just put that whole thing in an object that I'm calling myVar3. And then anytime I want to what's called call that vector, I can just type myVar3 and the program knows what I'm referring to. Now in R, you can use both that little arrow sign, which is like a left caret followed by a dash. You can also use an equal sign. I use the arrow partially just because I prefer the aesthetics of it, and because there's a hotkey for inserting an assignment operator, and that's the default way it is. But when I first started to code, I used the equal sign a lot. Technically, they're not actually identical, but for our purposes they are. And so if you're more comfortable typing an equal sign rather than typing the arrow, I'm perfectly fine with that. Now, you can store just about anything in an object. You can store strings, which are essentially letters or characters, as well as words. You can store numbers, and this can be like simple numbers like I've got on the left, so 2, 3, 4, 5. But they can also be like fractions and decimal places, so you can store the number 0.235587225. It all works the same way. You can also store vectors, and that's what I have on the bottom. And a vector, we're not going to get a ton into the math of vectors. That's like a whole linear algebra thing. That's technically important to the underlyingness of statistics, but not a bit too much for our purposes. All you need to know is that vectors are oftentimes like a list or a series of letters and or numbers. And finally, we can store entire data sets. And this is what you did in assignment 1. You took that entire monitoring the future data set and you put it all into an object. And that's pretty nice because then you don't have to read in that data set multiple times. You can just refer to that object whenever you need to reference the data set. There's a ton of other things you can store in an object, but these are sort of the big ones that we'll be working with. R also doesn't care about something called white space. And white space is the space between your objects and assignment operators on a single line. It can also be spaces between, let's say, parentheses. However, you can't have white space within an object name. So you can see my examples down here, myVar with no spaces, followed by like one space, an assignment operator, another space, and then dog is the same as that second line where there's a lot of space between the assignment operators and the value being assigned. R doesn't care about that. However, it does care if there's spaces within an object name. So that third line where it's myVar and there's a space between them, it doesn't like that. It thinks that those are two separate objects, and that's essentially an invalid command that you've put there. It also cares about spaces between letters within a string. So for instance, if I had dog written out in the quotation marks, but there was a space between the O and the G, that is different than dog without a space. And I think a lot of you figured this out from trying to load in your data sets in assignment 1. The way it was written in the assignment, there weren't any spaces because there didn't used to be spaces in how that data set was saved. Newer versions have spaces, and basically R reads anything within quotes very precisely, very exactly. And so it does care about white spaces in that context. R also cares about line breaks. And a line break is just when you press enter. So if you type something in, you press enter, and you're on a new line, that's considered a line break. You can only have one command per line. Like you can actually have multi-line commands if you connect them a certain way, but otherwise R considers line breaks to be new arguments, basically. It also cares about case. Basically, are letters capital or lowercase? So myVar with the V capitalized is not the same as myVar with the M and V capitalized, or myVar with just the M capitalized. So if you're ever having issues, if ever you've typed in like an object name and R is going, oh, I don't recognize this. I've never seen this variable before in my life, sir. You might just have a typo in terms of capitalizations. In addition to objects, R also uses functions, and functions are just a thing that takes an input and gives you some kind of output. Functions have what are called arguments. That's what you call the inputs that are required to work. Different arguments are separated by commas in R. There are two different ways that you can write arguments in R. You can explicitly name the arguments. So for instance, there's a function in R for finding the mean of a variety of values that you put into it. But there are other options that function has. So for instance, you can do this thing called trimming, which is like to take the last little bit of a value off before you average them together to prevent things like outliers or other weird stuff from happening. You can also remove missing values. So for instance, if you have a data set and some of those values are missing, they'll come up as what's called a NAs. And by default, you can't take the mean of values that have NAs in them. It'll just reproduce like this NA response. And so one of the things you can do is say, hey, could you please remove this NA from the calculation? Basically just drop it and calculate the mean of the values that I do actually have access to. We'll get more into how to use the mean function later, but the point is there's a bunch of different options you have for just this one simple function. And so you can either explicitly call them by actually writing out their name, so trim equals whatever you want it to be, NA remove equals, in this case, false, but you could say true and it'll remove the NAs. You can, however, not include those the names of the arguments so long as you put the arguments in the order that the function is expecting them. So for mean, it's expecting you to put the values that you want the means of, whether or not you want it trimmed, and whether you want to remove the NAs. If you put all of them in exactly that order, it will also work. However, because you are all learning, I would recommend always writing out the different arguments within a function so that you know what it is that you're doing. The other nice thing about that is that if you are calling particular, or if you're using particular arguments, you can actually change the order if you're specifically naming them. So in addition, we'll make a distinction sometimes between what are called base R functions versus packages. Base R is the set of functions built into R. So like by default, when you download the R programming language, you get a bunch of functions that go with it. The mean is one of them. Creating vectors is another one. Creating a sum is another one. But you can also download packages, which are sets of functions that you can download into R using RStudio, and they let you do a bunch of cool things that you can't do that you can't do with R by itself. So for instance, we did that with the Haven package last week. By default, R doesn't have a way to read in .sav files or SPSS files, but the Haven package is like an external package that we read in that does know how to deal with SPSS files. And so we can often solve a lot of problems by using other packages. And so it's just worth noting which functions come from which packages so that you can reproduce your work later on. A common property of pretty much any programming language is the idea of comments. So these are lines of code that are not executed, they're not run. And using comments can be useful to comment out lines of code that you don't want to run. So maybe there's something that's not working correctly and it keeps throwing up an error and you're like, you know what, I just want to hide this from my overall commands for the moment and just run the code that's working. But I don't want to delete this code, so you'll just comment it out. You can also use comments to annotate your code, i.e. describe what your code is doing. And for this latter reason in particular, you should make liberal use of comments to make sure that you understand what your code is doing. So for instance, here's some lines of code from assignment 1. On the left, there's no comments, and on the right, there's many comments. And so what you'll see on the left is that, like, yeah, maybe you're familiar with those. Like I know that because I'm very familiar with R, I can look at that and I can pretty quickly understand what the code's trying to do. But I have to work a little bit at it. So it's all bunched together, and there's no comments to kind of help guide me to tell me what I'm trying to accomplish there. Whereas on the right, it's actually a lot easier to read because if I was unfamiliar with any of these commands, I would have to look each one of them up. Or maybe I was the one that wrote it and I just forgot what I was trying to accomplish there. So if I'm like, well, why am I setting this groundhog folder thing? It's like, oh, I'm trying to save the groundhog data in the same folder as my current file. Okay, cool. I forgot about that from when I wrote this code 6 months ago. And so you can see it makes it a lot easier to remind yourself of what you are trying to accomplish. So you also have things like, oh, why did I load in the Haven library? Oh, because I'm trying to read in an SPSS data file, and that package is going to help me do that. Why did I load in the groundhog library? Oh, because it snapshots my library for future reproducibility. That's right. You can also see at the top that I've used comments in the other way, so commenting out commands I don't want to use. So for instance, when you're installing packages, you only have to do it once on your machine. But it's nice to keep it there so that if you were ever to share this data file with, or this R code with somebody else, they would know that they might need to install the packages first. And so you can comment them out, but leave them there. And that way, when you run this entire code block, you're not reinstalling the packages every single time because you don't need to do that. So two different uses of comments, both super helpful. Not only does it make your code a lot easier to read, but it's a good reminder of what you are trying to accomplish with each piece of code. And for all of you learning, it makes sure that you know exactly what you're doing with every line of code. And this is essential for students learning R. I mentioned earlier that RStudio includes a lot of quality of life improvements to using R, and one of the things I find most useful about RStudio is keyboard shortcuts. Now you can sort of Google online for RStudio keyboard shortcuts. You can also go to Tools, Keyboard, and followed by Keyboard Shortcuts Help to find what the common keyboard shortcuts are. But here's a few that I wanted to highlight that I use basically any time that I'm ever coding. And it's worth learning these particular keyboard shortcuts just to make it easy so that you're not having to click things all the time. It lets you keep your fingers on the keyboard. And you might, again, not think that you care about that, but the more you code, the more you'll find that you really don't like having to point and click all the time. So a big one is to insert the assignment operator, so that little arrow that I showed you earlier. It saves you the time from typing it every time. Yeah, you can press the equal sign and it's fine, but you can use the keyboard shortcut and it will insert it with the spaces on either side so it looks nice and aesthetic, and I prefer that. You can also press either Control or Command Enter. A lot of these shortcuts are going to depend on whether you have a Mac or Windows. But pressing Command Enter will run the current line that you're on. And so it lets you execute lines of code wherever your cursor is. Note, you can also highlight portions of code and use the shortcut to run only the highlighted portion. And this is really useful for troubleshooting. If you've got like a nested set of functions and you're trying to figure out what the issue is, sometimes what I'll do is just run a piece of the code to make sure that that little piece is working. And then I'll run the bigger thing, because sometimes the issue is like, oh, like this little part of my command actually doesn't work, and so I've got to fix that bit. Or, oh, this little part does work, so the issue's somewhere else. You can also use keyboard shortcuts to execute a current chunk, and so that's like the series of code lines that you have that are in between the little backwards tick marks in your R Markdown file. And so you can run all of the commands within a single code chunk wherever your cursor is. And finally, you can use keyboard shortcuts to comment or uncomment some selection of code. And so again, this is pretty nice if you're either trying to comment out a whole section of things, or if you're just trying to comment out little pieces of it or uncomment them. Note that power users can actually modify these shortcuts by going to Tools and then Modify Keyboard Shortcuts. I've done this for a couple of things. And if you're that kind of person, you're welcome to modify the shortcuts to your liking. If you're not, you can just use them as is. There's built-in ones. And if you're sitting here going, I don't understand what a keyboard shortcut is, they're basically ways to run commands from your keyboard. So for instance, if you've ever pressed Command C or Control C, depending on which operating system you use, to copy something, that's a keyboard shortcut. That prevents you from selecting the text, right-clicking, pressing copy, going somewhere else, right-clicking, pressing paste. So keyboard shortcuts just make it easier to do computer commands without your fingers having to leave the keyboard. RStudio also has this nifty function called autocomplete. And basically, if you begin typing the name of something that already exists, so an object that you've created or a function, you can press Tab, and RStudio will give you a list of possible things that could complete what you've typed in. So you'll see on the left here, I started typing ROU, and it's told me that there are basically 3 functions that could start with ROU. Oftentimes you don't even have to press Tab. RStudio will just automatically suggest options. This depends on how your preferences are set in RStudio. Uh, Also, if there's only one possible option, tab will simply autocomplete. So for instance, I was making all of those variables earlier called my there. If I had typed in MAMYV and pressed tab, it would have just auto-completed to my there. Until I created a my there 2, my there 3, and then when I'd press tab, it would give me all of those variables as possible options. When you have multiple options, you can use the up and down arrow keys to scroll through them, and then press enter when you've highlighted the thing on the list that you want. So this is useful because, as I mentioned before, R is a little bit finicky with things like capitalizations and spelling and stuff like that. It's very ungenerous when you make mistakes like that. And so autocomplete prevents you from making those mistakes because R knows exactly how it's typed. And so if you just let R autocomplete for you, not only is it faster, but you're less likely to have typos. The final cool thing I want to talk about in RStudio is purely aesthetics. So I'm very finicky with how my computer screens look, and I'm a big fan of dark mode type stuff. And so if you're the same way, if you see that bland old white background and you're like, I kind of hate this, or if you're wondering why my screen looks different from yours, because I'm sure it does, uh, you can change the colors or appearance of your code. And the way you can do this is you can go to the Tools, Global Options, Appearance. So you'll see I use a MacBook, and the way my screen looks is on the left. So you can go to the editor theme and just click through the different options to preview them. So personally, I use Cobalt. I've tried different things over the years, but I tend to like Cobalt because it's got this really bright syntax highlighting. So you can see like functions show up as this sort of bright orange, strings show up as this bright green. I just find it really easy and readable. It's dark, so it doesn't hurt my eyes, but it's not too dark. But again, you can pick whatever your aesthetic preference is. So if this is something that you're interested in, if you want your console to look cooler, I guess, you can follow these instructions and pick a syntax highlighting that you like. Now that I've covered all of the cool features of R and RStudio, I want to talk a little bit about how to troubleshoot R. Because taking this class, using R ever, you're going to do a lot of troubleshooting. So the first thing I want to say is troubleshooting is an art. It is not an exact science, and at first it will take a long time to fix even simple problems. I think you all sort of felt this probably on your first assignment, little things like just trying to read in data. You're like, what does this argument or what does this warning mean? What's going on? You don't know a lot about the language, and so it's hard to even know where to start for troubleshooting. But rest assured, you will get faster with practice. So as a quick checklist, when something goes wrong, check to see if you're missing any commas, parentheses, quotation marks, etc. A lot of these things should be auto-paired. So in RStudio, if you type an open parentheses, it'll automatically close it for you. But, sometimes you miss things anyway, so check for things like that. Check, are you using the appropriate case? So have you typed things with an uppercase letter that needed to have a lowercase letter? Have you spelled things correctly? I repeat, have you spelled things correctly? This used to throw me off all the time. I was so sure that I hadn't made a mistake in how I'd spelled something, and it turned out I had. Another thing you can try is restarting your R session. And so on my Mac, I go to at the top toolbar, I go to Session and then Restart R. What this does, it restarts the R program, but it doesn't restart all of RStudio. And sometimes there's just like, R is weird. Sometimes things get saved in the environment funny, or it gets set in a particular way, and you can solve problems just by restarting your R session. That said, make sure to save your work first, because you will lose potentially some amount of information by restarting R. That said, you won't lose information that's in your R Markdown file, because that's an RStudio document, not an R document. If that doesn't work, if you're still getting weird issues, try closing and reopening RStudio. And note, you should reopen RStudio by opening the R Markdown file you were working in. So like go to that file in your file browser, double click it, open it. The nice thing about doing that is when you do, R will automatically set the working directory to the file or the folder where your R Markdown file is. And so that's pretty nice. It makes things flow a little bit better. And so I always recommend doing this. I had to do this the other day where R RStudio thought I was still working in a project that I wasn't, and it was freaking out at me. So I just closed it, reopened it, and it was perfectly happy. So sometimes R RStudio just needs to take a nap, and that's fine. Now, let's say that you've gone through all of the quick checks, and none of that seems to be the issue. The general way to troubleshoot is to first consult the cheat sheets and reference PDFs. They're posted on Blackboard. They're in like the course content. There's a references folder. And there's various cheat sheets for like how to use R Markdown, common commands in R, stuff like that. I will add things to it as I find them. And so consult there. They might have some information. The next thing to do is to Google the error message, being sure to include R in your query. So here's an example of trying to troubleshoot an issue. So I got this error when I was playing around with R where it said my there, error object my there not found. And so the way to interpret that is that it's saying that it doesn't know the name my there as an object. It's saying I've never seen this thing before. Now, because I'm familiar with R, I kind of knew how to fix that problem immediately. I hadn't created that variable in the first place or that object. But let's say I didn't know. The first thing I'd do is type in the Google bar below R error object not found. You kind of want to generalize a little bit what the error messages are because my there is idiosyncratic to you. It's a thing that you've created. But having an object in general not be found, a lot of people would have that error. And so you can see there's lots of different autocomplete options. Google's actually very familiar with people Googling R error object not found. You can then look through the possible options, and usually people on something like Stack Exchange will explain what the problem is. And so that's one way to fix your errors. Note that sometimes you will fix an error and then you will create a new error or a new one will pop up because you'll only kind of see one error at a time. That's fine. Just keep Googling. I think to get your PDFs to render properly for assignment 1, I had to fix like 5 different errors that I had created for various reasons. This is super common. If you're Googling, you're doing something right. Finally, if Googling fails, post your problem as a thread on the Blackboard forum entitled Coding Problems. And I request this for 2 reasons. One is to allow each other to help each other out, because almost certainly if you have a question, if you're running into a problem, I can almost guarantee you that somebody else has that problem. I can also potentially guarantee you that someone else might have solved that problem. The other reason to do this is because these problems are so common, it's a lot easier on my end if I can answer the question once in a place where everyone can see it, rather than answering the same question 30 times over email. And the other nice thing about this is that if you ever run into that same problem again, you can go back to that discussion post and see what the solution was. So that's another reason to do that. So if you've consulted the cheat sheets, if Google has failed you, post your problem as a thread on the discussion forum, and we'll hash out the issue there. The last thing I want to point out for helping you troubleshoot R is to use the built-in help function. There's a lot of ways to do this. The easiest to me is to just go to your console and type a question mark followed by the function that you want the help file for. So this is not super useful if you're trying to troubleshoot a specific error, but if you're not sure how a function works, if you're like, oh, what are all the various arguments for the mean function or the round function, you can do this question mark followed by round. It'll autocomplete for you. You press enter, and then it will take you to this help page in the help tab. The other thing you can do is you can actually click on the help tab itself and use the search bar in the top right corner and search for the command you're looking for. This is very useful if you're not sure what the default arguments are because some functions will have default arguments. So for instance, the mean function by default assumes that you don't want to remove NAs. And so you don't have to specify that you don't want to remove NAs if you're happy with that default. However, if you want to change the default, you may need to know what the arguments are that you can change. And so help files are useful for just understanding how functions work and what they're expecting from you and what kinds of outputs they'll give you. Note that reading help files is an art. They're often weirdly obscure, and it takes a while to get comfortable reading them, but I promise there is useful information in there. It's just a little bit like deciphering another language, but you will gain fluency the more you do it, and so I do recommend reading the help files anytime you're using a new function that you haven't used before.